So we're ready to separate a mixture of compounds. So we go here, and this will be your things to do. You'll download your lab and report handout here, and it'll look like this. You'll want to fill out your purpose. You want to do some research into chemical separations. What do they depend on? How do they work? And you'll do the procedure. In this lab, we're going to be we have a mixture that has ammonium chloride, sand, and sodium chloride in it. We're going to separate those three items. So let's go down here to the lab. Your mixture is way over to the end. I believe that's it. Nope, even farther. There it is. So you go way far to get your mixture. You'll get 15 grams of it. You'll need an evaporating dish. You'll put your 15 grams of your mixture in. You will need to know the mass of the evaporating dish. You'll heat the evaporating dish up on the Bunsen burner, and it will get lighter because ammonium chloride is given off as a gas. You have to get it pretty hot to have all the ammonium chloride gone. When you're done, you'll let it cool before you weigh it. So make sure that it's cool before you weigh it. Then you'll transfer what's in this dish, which is the remaining sodium chloride and sand, into a beaker. You'll need to weigh the beaker first so that you'll know what the beaker weighs. You'll add some water, and then you'll be able to decant the salt water away. And you'll have a beaker full of just sand, and you'll have another beaker that has salt water in it. Boiling away all the water will leave you with a beaker just full of salt. Okay, so let's look and see where you're going to put all this information when you have your report. Okay, so the first thing you're going to need is the mass of the empty weighing dish, the evaporating dish. I could call it a weighing dish. That's that white dish I showed you at the beginning. That's what you're going to heat the mixture in. You'll need to also have the mass of the evaporating dish with the powdered mixture. By subtracting these two figures, you'll get the mass of the powdered mixture. Okay, so that's important because you need to know how much you start with. Part 2. Mass of the evaporating dish and contents after heating. Remember I said you were going to put that evaporating dish on the Bunsen burner. You're going to get it, it has to get pretty hot to burn off all of the ammonium chloride, or to have it evaporate. It doesn't really burn off, it evaporates. So you'll have the mass of the evaporating dish after heating, and that'll go here after it's cooled. Now you need to calculate the mass that has been lost, which is the mass of the ammonium chloride. So you subtract the mass of the evaporating dish and contents after heating, which is here, from the mass of the evaporating dish and powder mix, that's before heating, that's up here. Okay? And that will give you the mass of the ammonium chloride. If we take the mass of the ammonium chloride and divide it by the mass of the powder mixture, which is here, you'll get, at times 100%, will give you the percentage of ammonium chloride in the sample. Okay, I told you you needed to mass a beaker. Then you're going to transfer the contents of the evaporating dish into that beaker. You'll add some water, mix it up a little bit, and you'll decant off the salt water. That will leave you with a beaker full of sand. Not full, but it'll have sand in it. You'll need to know how much that weighs. By subtracting off the mass of the beaker, you'll get the mass of just the sand. Once you have the mass of the sand, you can divide it by the mass of the sand. Take the mass of the sand, divide it by the mass of the powder mixture, and you will get the percentage of sand in your sample. Okay, remember I said you had now a beaker full of salt water. You need to know the mass of the beaker before you added the salt water to it. That goes here. Then we need the mass of the beaker with the salt after the water's boiled away. Put that mass here. Subtract these two, you'll get the mass of the salt. We take the mass of the salt and divide it by the mass of the powder mixture that we started with. We'll get the percentage of salt in the sample. So if you've done all this correctly, your percentages should add up to 100%. If they don't, contact me, let me know. Now, part of doing good science is calculating your error. And we're going to assume that this is the true or accepted percent. Is 15% ammonium chloride, 60% sand, and 25% salt. So you're going to calculate your percent error for each of your values. The accepted value is the value that you calculated. So since salt is down here, we'll do salt. It would be this value right here. I'm sorry, the accepted value is the accepted value. It's this one, 25. The calculated value is this value. And then you divide it by the accepted value times 100%. And that'll give you your percent error for each of the things, each of the parts. Okay, and then I need a conclusion. Good luck, and contact me if you have any questions. There are a lot of different measurements in this lab, and it can be very confusing. If your percentages don't add up to 100%, you've made a mistake. I can help you find it.